Hello, everyone. Hello, good afternoon, and welcome. If you're here for a talk titled Bulletproof Backends, you're in the right place. If you are not here for a talk on Bulletproof Backends, you are also in the right place, as you will not be allowed to leave. So, I was up at about 2:30 this morning, like you do before you have to give a presentation, and I thought, this is probably a very API literate audience, so the real sizzle in this presentation is the demo. So what I am going to do is blow through these slides pretty quickly, and then if anyone has any questions, they can say, hey, Sean, I don't know what a breaking change is, for example, and then I can stop and kind of go into detail. This talk is called Strategies for Building Adaptive Services with Hypermedia. Has anybody never heard of hypermedia before? Okay, everybody's familiar with hypermedia. Awesome. I'm not going to talk about it today. This is not a hypermedia talk. This is about building adaptive services. What do I mean when I say adaptive services? I mean services that can absorb change. How many of you, by a show of hands, either you within your organization or your dev team, have grumbled when you hear of the prospect of new business requirements, new product requirements that require a change in the system? Anybody? Everybody? Okay, cool. All right, I was going to say, everybody loves change here? Amazing. So you are part of the problem, okay? But you're in luck because my name is Sean and I'm here to help. But first, who am I? When I am not cross-hatching the globe giving technical talks, I am in Brooklyn, New York at a company called Redeem, working as the head of platform. Redeem is a personalized fintech platform, and right now our core product is a Chrome extension that automatically recommends the best credit card for you to use as you're shopping along the internet, such that you can maximize the benefits, rewards, or offers associated with all of the credit cards in your wallet. But I'm not here to talk about that. I'm here to talk about adaptive services. So what this talk is, I'm going to offer a modest proposal for how you can change the way that you think about how web services can be designed and can communicate with each other using self-describing messages. I'm going to show an actual business case of a service radically altering its API contract without breaking its dependent clients. And hopefully, in the end of this, I'm going to persuade you to think about using this API design strategy in your own companies, if for no other reason than to save your developers some toil, maybe get them out of some meetings, and who knows, maybe even escape some meetings yourself. Because killing meetings is actually the real point of this talk. Show of hands, who loves meetings? Okay, this lady. All right, awesome. Listen, there's always one. So, okay. This is where I talk about some stuff that you probably already know about. So breaking changes. Why do web services break? For all of these reasons here, but we're zeroing in on the breaking changes. And here are the usual suspects for those breaking changes. So new required fields, something that used to be optional is now mandatory. Changed message structure. We've changed a field name. We've gone from first name to given name, or from last name to surname. We've also changed the field location, so maybe that name information is now nested under a customer object, where it used to be at the root level of the object. Or we've changed meaning, so we've gone from an object to an array, or an array to an object. In all of these cases, changes of this nature will break our existing clients. Cool, we're going to talk about these things called self-describing messages, but first we need to touch on the structure of messages and why the structure of messages is even important. Again, along the side here, these are the top reasons why the structure of messages that are passed between services is really important. But I'm going to make a bold claim. I'm going to claim that the structure of messages is actually less important than the meaning of the messages. The message structure, the shape of the message, is an implementation detail. It's an important implementation detail, but it's also an implementation detail that we're not really the best at addressing in current web architecture. In fact, the typical way that we do this is we have two services that need to communicate, and so we bind very tightly between two data models in these collaborating services. And of course, once we do this, we're in the danger zone because a change in one service requires a change in the other. And at that point, you've given up the game. The only way to communicate about change is to have a meeting, and your calendar is going to blow up. Question, how many of you are integrating third-party APIs into your services at your companies, right? A lot of people, of course. How many of you are creating mappers or mapping layers to reconcile different external data formats between or among services? Right, a bunch of people. Very, very typical. So your calendar, I'm assuming, is full of meetings, right? How do you all address, will anyone be brave enough to say how you address changes like this? You have a meeting, right? There's no other way around this. Cool. What do I mean when I say meaning versus structure? As you have probably gleaned instantly, these are all receipts. They all mean the same thing. They're all proof of a transaction that a purchaser gets to retain for their records. But they have slightly different structures. Some of them have different currencies. Some are for different goods or services. This one, for example, is an email receipt, and a couple of these other receipts have been issued from a POS system. But despite their structural differences, they all mean the same thing. If you're like me, you kind of like human beings. And so what human beings are good at is filling the semantic gaps between messages that mean the same thing but may have a slightly different structure. Currently, systems cannot do this today. We don't know what's around the corner with regard to AI or anything like that, but at the moment, it is very typical that systems cannot parse the meaning of the messages that they are exchanging in any meaningful way. This makes them brittle. And so my claim is systems designed to address message semantics are going to be much more robust than systems that do not take message semantics into consideration. So, self-describing messages provide a solution. What is a self-describing message? Thank you for your patience. It's a message that contains all of the data needed to interpret the message in the message itself. And my claim is that these self-describing messages are the key to system adaptability. This image is a fantastic example of a self-describing message. If you've ever received a package, certainly an international package, you've seen something that looks like this. And what is great here is that we are able to glean all kinds of information about this package without knowing what is inside of it. We know where it's come from. We know where it's going. There's a tracking number that's a hook into an external system that we can use to get more information about the package from the courier. There may be hints about how to process this package or this message, fragile or perishable goods, or urgent or express, indicating that we need to take specific precautions to move this to the head of our priority queue, or in the case of fragility or perishability, we want to make sure that we take the appropriate precautions. All of these things we know without needing to know what is inside of that box. And we also get this information without having foreknowledge about how to process different messages. Right now, systems are designed in exactly this way. We know all of this information ahead of time about every kind of variation of message that the system is going to have to process. And this is great as long as all of that foreknowledge is valid. But as soon as there's a change, everything falls apart. Now it's time for my real world example. Oh, wait a second. I missed that part. The title. This is called A Tale of Two Companies. So we're going to explore a really common business problem, and we're going to see how self-describing messages can offer a solution. So the first company is Muzak. It's an e-commerce storefront, and it sells digital downloads, vinyl albums, CDs, and cassettes. They have fantastic inventory management, but they don't have any metadata about all of the products they have in inventory. By metadata, I mean track length, artist information, genre information, that kind of thing. They're really looking for a partner who's going to be able to provide this metadata for them. What they want to do ultimately is surface this metadata on their individual product pages when users are browsing the Muzak website. Here is our partner, MetaMusic. It's a SaaS platform. It provides an API that allows us to query MetaMusic for an album or a track, and we get back metadata about that album or track in return. So it looks like this is going to be a great partnership. And the way that this works is a pretty typical architecture. The Muzak website is going to make a request to the Muzak API. Muzak is going to forward that request to MetaMusic. MetaMusic gives us back the metadata about the album or the track in question. And then Muzak ultimately enriches the product information with the metadata from MetaMusic and feeds it back to the website for the customer. But we have a problem. All is not well. MetaMusic is in the midst of a leadership shakeup. So 3 candidates are vying for the CTO role. And each of them has a very specific idea about what an API response format should look like. And even worse, each of these candidates forces the dev team to push their preferred version of an API response interface into production. This means that we have breaking changes on a daily basis. This sounds like a hellish place to work. I would not want to work there. How can we solve this? Enter a new character, JSON Patch. What is JSON Patch? It is a formal specification for describing changes to a JSON object. Fundamentally, we start over with a candidate object on the left. We have a series of patches, which are operations to apply to our candidate object. And then in the end, we get a new object with all of these transformations applied. What is great about JSON Patch, it is a formal specification. That means there are tools and packages already available that know how to operationalize all of these patch documents. What's great about JSON Patch is that it's just plain JSON. That means it can be serialized. Because it can be serialized, it means it can be sent over the wire. Because it can be sent over the wire, it means we can have a link to this document. And maybe you know where I'm going with this, but let's see. So it's demo time. What are we going to do? We're going to see all 3 of the API response formats from the MetaMusic API in real time at random with no logic that inspects the response of the payload. The only help that we're going to get from MetaMusic is in the form of a link to a JSON patch document that we're ultimately going to use to interpret the response payload. So Muzak is going to fetch this patch document and ultimately apply the patch to the response payload that it receives from MetaMusic, ultimately transforming the response payload into something stable and consistent for Muzak's web client. So we're moving from a volatile system to a stable one. So I'm ready for you. Please, God. Live demo. All right. Can my screen be seen? There it is. Perfection. Oh no, wait a minute now, I have to restart my thing. How am I doing on time? Beautiful, I love it. How's everybody doing? Nordic APIs, good, yes? Awesome. I have to everything was like butter, it was like clicking, it didn't. Okay, here we're coming up, hopefully. A little plug for GitHub code spaces. I love it. I don't do any local development on my computer anymore. I refuse. Everything is web-based. Okay, next thing. Let's get my Docker Compose up. No. Oh no. Let me give this one more try. Unbelievable. All right, I was prepared for this. In that case, can you cue up the movie that I prepared for this? Oh, see, you guys were thinking. You're like, well, I just tried this before this talk. This is really frustrating. The minute I sit down, it's gonna work again. Do I need to unplug my thing, yeah? Oh, it's up. I'm sorry, I missed it. Can you start it again? And is there a way to make it like slower? I know I'm doing a lot. OK, so we'll go over this a couple of times if, oh yeah, speed right there. Beautiful at like half speed maybe. This should be good. So hopefully this can be seen. But this is an example of the MetaMusic API. And this is what I was talking about. If you notice here, as I'm refreshing this request to the MetaMusic API, this response keeps changing its structure. So notice it goes from Pascal case to some sort of idiosyncratic type of structure, and it'll eventually go to camel case. And you can see here in this get patch schema link here, that's also a part of that API response. It's also indicating what is the version and the type of response that we are getting. So in a minute, what you're going to see is, OK. Me showing the patch specifications for each of these strategies within MetaMusic. So these are all of the instructions that cause it, or that cause the transformation of the, or rather enable the transformation of one API response format to another. So this is really the meat of how we're going from one shape of object to another shape of object. In a moment, we're going to see actually the request where we go to Muzak and we see a stable request. That's what this is all leading up to. So let us see. Where do we go, Shawnee? OK, so now we are inside of Muzak. And starting at the top here, first, this is where we fetch the album metadata from the MetaMusic API. This should look familiar. This is the get patch schema that was in the response payload from MetaMusic. Oh, that's just indicating that we're there. There's our patch schema. Beautiful. We come down here to our second step where we're actually fetching the patch schema document from MetaMusic. So this is when we actually get the specification we need in order to transform the document. Once we get it back, this is where we actually apply the patches we received to the response that we received from MetaMusic in the earlier request. And then lastly, down here, we return the album data enriched with metadata from MetaMusic. So I think that the last part of this demo, we will see the other tab there where continually refreshing the request to the Muzak API just returns the same API structure. There isn't any of that variability that we saw before. So that, oh yeah, here it is right here. This is the big one. Come on. So here we can see, again, because we have this link to the version that we're using for the patch that's provided by MetaMusic. And here we see that no matter how many times we refresh, the API response from Muzak remains the same. So it really doesn't matter what kind of executive drama is going on in MetaMusic. They can do whatever they want. They could add additional formats or anything like that. Or maybe they ultimately decide, you know what, we're going to go with the camel case format after all. This is the end of the movie. We're going to go with the camel case format after all. Doesn't matter. We don't need to care. We can still take care of our business at Muzak, and that is that to me is the most persuasive aspect of this entire talk. The ability to use these self-describing messages to absorb change and to hopefully kill meetings. Maybe not once and for all, but certainly kill more meetings than probably you ever thought possible. So that is the end of my talk. I hope that I have left a small splinter in your mind and that you will consider this API design strategy in your own services and applications moving forward. Thank you.